Hey guys, I wanted to explain to you number 71 on the 6.3 worksheet, okay? On the 6.3, section 6.3, okay? I'm sorry the lesson was cut short, but you can use the same kind of skills, okay? So let me explain to you number 71. It says that you have force 1, and you have force 2, and you have a resultant force, okay? That's the important. Resultant force is basically what happens when you apply force 1 and force 2. So this is V1, this is V2, and this is going to be our R vector, okay? They're all vectors, and this one is 45 pounds, this one is 60 pounds, and this one is 90 pounds, our resultant vector, okay? So guys, if you were to draw this as a diagram, here's what it would look like. Force 1, it tells you in the instructions that it only goes along the positive x-axis. That means force 1, you guys, V1, it goes this way. So this is V1, okay? That's V1, and that actually goes this way, okay? And this guy is our V1, which 45, and that's the magnitude, okay? And it says that force 2 is a vector at an angle of, okay, with an angle of theta degrees, okay? So that means our force 2 goes this way with an angle along the x-axis, and it's here, and that's 60 pounds, okay? And our resultant is actually when you move this, what do you get is this. This is our resultant. That is our resultant vector. Resultant force vector. So that's 90 pounds, okay? 90 pounds. So 45, 60, and 90. See if you understand that part. And you guys, now this guy, so we have our force 1. So our force 1. Let's talk about our force 1. Force 1. It doesn't have a vertical component. It only has a horizontal component of 45. So our horizontal is actually just going to be, let's call this V1, it's just 45, okay? It's the horizontal component. Let's actually call it, oh, I know, let's call it V of X, okay? We just have a horizontal component, V of X, okay? Now, force 2, though, it's got a vertical and a horizontal component. It's got the horizontal component here and the vertical component here, all right? That's the vertical and horizontal, and this is their theta. So watch this. So we'll call this guy U of X and U of Y, okay? That means our U of X is going to equal what? And U of Y is going to equal what? We talked about this in class, so it's basically U of X is going to be our cosine 60 cosine theta, because cosine of theta is adjacent over hypotenuse, right? And that's 60. Our vertical component is going to be 60 sine theta because it's opposite over hypotenuse, and we readjust the equation so it becomes solving for the actual vectors, okay? Now, our U plus V, because this is our V, this is our U. So we call this V and this U, okay? You guys, so really, this guy is actually U of X, V of X. Yeah, we had that, right? But I'll write it prettier. So U plus V is actually equal to our horizontal component, 45, plus our horizontal component from here. That's for our resultant vector. Okay, I'm sorry, I didn't specify that. Okay? And our vertical is actually just 60 sine theta. We don't know what theta is. But you guys, that's good. Okay, and they gave us the magnitude of that. So you guys, we can set it up. Magnitude of U plus V is going to equal 90 because that's given, okay? And that vector is actually, how do you find the magnitude of this vector here? It's essentially the same formula. So it's 45 plus 60 cos theta squared plus 60 sine theta squared. And that's how you find the magnitude. Okay, and they go through the solution guide actually shows you how the calculations occur. And what you get is that you get cosine, when you solve all this, okay? When you solve all this, like everything goes away, and all you're left with is cosine theta is 2475 all over 5400. That's why theta is 62.7 degrees. That's our theta angle here. That's called a direction angle, okay? That's it. That's really it. That's really it. If you're confused about this part, please ask me in class, and that's number 71, okay?